Now we can move on to the properties of its common multiples. However, there's not that much properties in LCM, but I want to show you a problem that is very magical and shows one of the properties of LCM, and it is really important. So now let's see this problem. Prove that LCM of A and B equals to A times B over GCD of A and B. So first, let's make GCD of A and B equals to D. Thus, A equals to D times A1 and B equals to D times B1. Next, we make C be one of the multiples of A and B. Thus, C has a form of just AB divided C. Okay, so we can make C equals to A times C1, and it follows that B divides A times C1. Let's make that to a fraction. So A times C1 over B, and A equals to D times A1. So D times A1 times C1, and B equals D times B1. D times B1. And D can be cancelled out. So A1 times C1 over B1, that's an integer. However, as we learn from the properties that A1 and B1, the GCD of A1 and B1 equals to 1. So it follows that B1 divides C1. Thus, that C1 equals to B1 times X. And let's make it back to the number C. So C equals to A times C1. A times C1. And where C1 equals to B1 times X. A times B1 times X. And A equals to D times A1. That equals to D times A1 times B1 times X. Thus, this number is A, and we can times B, and we can times D for B1 to make it to B. So B1 times D over D times X, and that becomes B. So that equals to A times B times X over D, where D is the GCD of A and B. So that equals to ABX over GCD of A and B. So we can see that as a multiple of A and B, C has the form of ABX over GCD of A and B. So the least common multiples of A and B is one of the multiple of A and B, and it is the least one, so X equals to 1. So we prove this question, and this question is very important because it follows that if you have two integers, and it has a property that LCM of that two integers times GCD of that two integers, and that will equals to AB. Now let's see the first question, that GCD of A and B equals to 1. Prove for the sum of the quotients of A to A3 and to B minus 1A upon derivation by B is equal to a minus 1 times b minus 1 over 2. So let's make the form of these numbers as a equals to b times q plus r, because we are making the division of a upon b. So 1a equals to b times q1 plus r1, and 2a equals to b times q2 plus r2, and b minus 1 equals to b q or b minus 1 plus r b minus 1. So in these forms, let's first prove that whether b divides a or not. So that means one of these r is equal to 0, so a divides b. So let's take k as k bigger than or equal to 1 and less than or equal to b minus 1. So it also has a form of ka equals to b times qk plus rk. Since rk equals to 0, we have ka equals to b times qk. However, this follows b divides ka, and since GCD of a and b equals to 1, so b divides k. But k is less than or equal to b minus 1, so this is a contradiction. So this will not happen. Rk does not equal to 0 for any r of these forms. Now let's prove that are any two r's on these numbers that are equal to each other. So let's make Rm and Rn. Let's make a question mark. So we have Ma equals to b times Qm plus Rm, and Na equals to b times Qn plus Rn. Since Rm equals to, let's suppose that Rm equals to Rn, so and combine these two equations. So m minus n times a, we subtract them, equals to b times Qm minus Qn. And since Rm equals to Rn minus Rn, that will equals to 0. So it follows that b divides a times m minus n. Similarly, b does not divide a because GCD of a and b equals to 1. So b divides m minus n. However, m minus n, m and n are chosen from 1 and b minus 1. So it cannot be possible that m minus n has the form of b. This is another contradiction. So this proves that for any r, they will not equal to each other. Hence, this means that the set of R1, R2 until R of B minus 1 is the same as 1, 2, 3 until some number n. That makes the question easier. So now let's expand. Let's add these numbers together and expand it. So a plus 2a plus 3a plus b minus 1a, that equals to b times q1 plus r1 plus b times q2 plus r2 until b times q of b minus 1 plus r b minus 1. Now it's easier to see that we can take every r from each combination. So r1 plus r2 until r of b minus 1 plus bq1 plus bq2 until b of q of b minus 1. So these numbers, you can simplify that as the first number 1 times 1 plus the last number of, which is b minus 1, times the number of r, which is b minus 1, over 2, and this equals to b. And these numbers, you can simplify this as b times q1 plus q2 until q b minus 1. So now let's look at the left side, a plus 2, a plus 3 until b minus 1. This is equals to 1 plus b minus 1 times b minus 1 divided by 2 times a, which is b times b minus 1 times a divided by 2. You can subtract this number from both sides. So a times b minus 1 minus b times b minus 1, and this equals to a minus 1 times b minus 1 over 2. And since we subtract this number from this side is left with b times q1 plus q2 until qb minus 1. So the question said prove that for the sum of the quotient of this number over b is equals to a minus 1 times b minus 1 divided by 2. So we divide b on both sides and we solve the question. Let's see the next question. Show that if a bigger than 1 and m bigger than 0 are integers, the GCD of a to the m minus 1 over a minus 1 and a minus 1 equals to GCD of a minus 1 and m. We saw a to the m minus 1, that is equals to a to the a minus 1 times a to the m minus 1 plus a to the m minus 2 times 1 plus all the way to a times 1 to the m minus 2 plus 1 to the m minus 1. In this case, we are dividing a to the a minus 1, so we divide a to the a minus 1 on both sides, and this get cancelled out. So, but in this case, this is equals to a to the m minus 1 plus a to the m minus 2 all the way to plus a plus 1. So for every individual a to some exponent right here, we can subtract 1 to make it divisible by a minus 1. For example, a to the m minus 1 minus 1, this is divisible by a minus 1. So we can keep doing that. A to the m minus 2 minus 1 minus 1 plus a to the m minus 3 minus 1 plus all the way to a minus 1 plus 1. 1 is the only number that cannot be divisible by a minus 1. So this whole thing is divisible by a minus 1, but we have subtracted m. There are totally m minus 1 times of a, so there are m minus 1 times of 1 in this case. So we need to add m minus 1. So we add m minus 1 at the bottom of this equation. So 1 plus m minus 1, this is equals to m. You can denote this whole thing into, let's say, q times a minus 1, because this is divisible by a minus 1, and we don't need to know the numbers q right here, plus m. So we have switched the problems to GCD of q times a minus 1 plus m, and a minus 1 equals to GCD a minus 1 m question mark. But we learn from the properties of GCD that GCD of a and b equals to GCD of b and r if a equals to qb plus r. So this is the case, like b is a minus 1 and q times b plus r is m, so that equals to GCD of b and m, which is a minus 1 and m. So this question is solved. That's basically all the problems that I have for GCD and Lcm. If you have any questions, please contact my email. So see you next time.